In this video, I'm going to show you how to use the 45, 45, 90 triangle to compute the values of some trigonometric functions at 45 degrees. So we want to compute sine of 45 degrees, cos of 45 degrees, and tangent of 45 degrees, and we're going to start by drawing out a 45, 45, 90 triangle. So let's get our straight edge and begin drawing. So 45, 45, 90 triangle. We know that there's a right angle at that 90 degrees, and we also know that since the other two angles are the same, that it's an isosceles triangle. So let's make a right angle. How about, say, 3 inches long on the side, and both of these sides will have the same length because it needs to be an isosceles triangle. So here we go. There's two sides of the same length, and then here is our hypotenuse. We'll just label this up nice. So there's our right angle, and then these two sides have the same length. Just to be complete, let's also write in the angle measures, 45 degrees here and 45 degrees there. Okay, so now let's put some side lengths on this triangle. These two legs are the same, so why don't we just say that they're both length 1 unit long, each of them. So how would we find the hypotenuse then? Let's call that c. Well, we can just use the Pythagorean theorem. By the Pythagorean theorem, c squared has to be equal to the sum of sides squared. So 1 squared plus the other 1 squared. So c squared equals 1 plus 1, which is just equal to 2. So taking the square root, c has to be equal to the square root of 2. So there we go. c is root 2. And there we've got our triangle, size 1, 1, root 2. Okay, so now let's compute some of these trig values. So first, starting off with sine of 45 degrees. How do we find sine of 45 degrees? Well, why don't we start off by picking an angle 45 degrees. Why don't we just say this one? This will be our 45 degrees. And we know that sine 45 degrees, that by SOHCAHTOA, let's write that up here. SOHCAHTOA, we know that sine of 45 degrees has to be the opposite O over the hypotenuse H. So let's label these. Opposite is 1, hypotenuse is root 2, and this will be the adjacent side. So opposite over hypotenuse, so 1 over root 2, and then we can simplify that a bit, multiply top and bottom by root 2 to get rid of that radical in the denominator, and then we've just got 1 times root 2 is root 2, and then root 2 times root 2 is just 2. So sine 45 degrees is root 2 over 2. Next up, let's do cosine of 45 degrees, and we'll just use that same 45 degree angle. So cosine of 45 degrees. First, let's look to SOHCAHTOA, cosine, CAH, so that's adjacent side over hypotenuse. And looking to our diagram, adjacent is 1, so 1 over hypotenuse is, again, just root 2. So this is the same as before. We just multiply by root 2 over root 2 to get root 2 over 2. It's the same thing as sine. So sine of 45 degrees is equal to cosine of 45 degrees. Lastly, let's take tangent. So tangent of 45 degrees, according to SOHCAHTOA, that's just opposite over adjacent, and we'll look to our diagram to get that information. Opposite is 1, and then adjacent is also 1, so 1 over 1. Tangent of 45 degrees is just equal to 1. Now, it's important to note that these ratios here are always true. Sine of 45 degrees is always root 2 over 2, cosine of 45 degrees is always root 2 over 2, and tangent of 45 is always 1. It doesn't have anything to do with the particular triangle that we drew at the beginning. That was just one way to arrive at these special angles. If we started off with a different side length of the triangle and computed our hypotenuse based on that, and then plugged those in the formulas for the trig functions, we'd get the same exact results. So now we can use these results in various applications. And from now on, we'll simply quote these results, so it's useful to have them memorized going forward. Alright, here's an example. So without using a calculator, want to compute this expression, 2 sine of 45 degrees plus 3 tangent of 45 degrees. And we're going to use our trig ratios that we derived on the previous slide to help us here. So now that we know what these ratios are, we can just plug them into the expression. Sine 45 degrees, we can just plug in root 2 over 2. So let's go ahead and do that. Let's write it again. So 2, but then times root 2 over 2. And then for tangent 45 degrees, so let's write plus 3, and then tangent 45 degrees, that can be replaced with 1 here. So plus 3 times 1, and then we just have to compute this. So 2 times root 2 over 2, well, the 2 is going to cancel with the 2 in the denominator, and we'll just have root 2, and plus 3 times 1 is 3. So there we go. That's it. That is our result. All right, next example. Again, without using a calculator, compute 8 sine squared of 45 degrees minus 4 cos squared of 45 degrees. Okay, so this is kind of like before. We're going to end up just plugging in these trig ratios into the expression here. But let's first talk about what the squared means. So sine squared of 45 degrees, that might look a little odd, but all that really means is sine of 45 degrees, take that value and square it. So why don't we rewrite this expression in a more familiar way. So 8 and then times sine of 45 degrees, that quantity squared, and then minus 4 times cosine of 45 degrees, that quantity cosine 45 degrees squared. So now we can just go ahead and substitute in for sine and cosine of 45 degrees. So first of all, let's substitute in for sine of 45 degrees. That'll be root 2 over 2, and let's keep the rest of that side of the expression. So that is going to be squared and then multiplied by 8, then minus 4 times, we'll put the cosine of 45 degrees in here. Also, cosine of 45 degrees is just root 2 over 2. And now we can go ahead and compute. So let's square this. So that's 8 times, well, it's root 2 over 2 squared. That's just root 2 squared over 2 squared. So 8 times root 2 squared is just 2. And then 2 squared is just 4. And then minus 4 times root 2 squared, again that's 2, and 2 squared, again that is 4, and we can compute here. Why don't we simplify first? So this is 8 times a half minus 4 times a half, and we can cancel. So 8 times a half is 8 divided by 2, so that's just 4. Then minus 4 divided by 2, that's just 2. So 4 minus 2, that's just 2. And that's what our expression comes out to. All right, last example here. So we want to find the lengths of the legs x and y in this 45, 45, 90 triangle without using a calculator. So again, we're going to use these values that we derived earlier to help us out here. So why don't we set up a trig function which involves these sides x and y. So each will get its own equation, and then we'll be able to solve. So how about we start with this 45-degree angle here. So how about sine of 45 degrees? That's just equal to y over 7 root 2. So then we can solve. So why don't we do that? Sine of 45 degrees. We already know that's root 2 over 2. So we'll be able to simplify that equation. So that's opposite over hypotenuse. So y over 7 root 2. And then let's go ahead and substitute in for sine of 45 degrees. That's just root 2 over 2 equals y over 7 root 2. So just multiply both sides by that denominator. So root 2 over 2 times 7 root 2 is equal to y. And then, so this root 2 times root 2, that'll make 2, and then divide by 2, and that'll cancel out. So we can cancel out all of these, and we just have y equals 7. There we go. All right, and now how about x? So why don't we choose the trig function that relates x to the hypotenuse here, 7 root 2. That's just going to be cosine. So let's write that down. Cosine of 45 degrees, that's equal to adjacent over hypotenuse. So So x over hypotenuse, 7 root 2, and we can sub in for cosine of 45 degrees. That's just root 2 over 2. We already know that. So root 2 over 2 is equal to x over 7 root 2, and again we can just multiply both sides by that 7 root 2, get root 2 over 2 times 7 root 2 equals x, and then root 2 times root 2, that makes 2, but then divided by 2, that cancels out, so cancel out all of these terms, and we just have x equals 7. There we go. So x equals 7 and y equals 7. And it makes sense that they're both the same result, because this is an isosceles triangle. It has two equal base angles, so the legs have to be the same. So great, makes sense. So now we know how the 45, 45, 90 special triangle can be used to find the exact values of the trig functions at 45 degrees. In the future, we'll also do a similar thing with another special triangle, the 30, 60, 90 triangle.